Welcome to the very first episode of Resilience Testing Talks. Today we have a very special guest joining us for this podcast. He has more than a decade of experience in tech and currently he is working as a senior developer advocate at Improving. He's one of the organizers of CNCF Hyderabad and he was one of the co-chair of KubeCon India 2025, which was held in Hyderabad in the month of August. I'm pretty sure you must have guessed him already, but just to tell you a bit more about him, he's also a CNCF Ambassador and one of the most active personalities in CNCF India ecosystem. His name is Atulpriya and we are super glad to have him on our first episode of this podcast series. So Atul, let's start with a quick introduction of yours and a quick insight on your CNCF journey.
Sure. Thanks a lot, Pritesh, for having me here. It's great to know you outside of work as well, and it's glad to be connected here as well. So, in terms of introduction, I think you did introduce a bunch of things of what I do. So yeah, I do everything that Pritesh has mentioned, focusing mainly on CNCF technologies, tools, platforms, landscapes. My area of interest is platform engineering. That's where I focus mostly on. Obviously, I'm spending a lot more time picking up AI on what's happening as well. And as part of my community efforts, I'm a CNCF ambassador. I do meetups. I've spoken at KubeCons, KCDs. So there are a bunch of things that I have done. Now, before I get into how my journey started within the CNCF, I've been working for over a decade, and I started as a manual tester, so manual QA. So I remember, joining one of the big service companies here in India, and going through Excel sheets, having test cases, going to a website, clicking a bunch of buttons, and then marking them pass and fail within the Excel sheet to ensure whether the test case is passed or fail or not. So that's how I started. Did that for a year or so, I guess, and then moved into automation testing, where I again, elevated from manual to automation, where I started writing scripts. So I was interacting with code, VS Code, back then Visual Studio editor and stuff. So I've done a bunch of things before getting into the CNCF landscape, which happened when I was at InfraCloud. So InfraCloud got acquired by Improving earlier this year. So I joined InfraCloud in 21. And that's when my journey within the whole CNCF ecosystem started. So I wasn't quite aware of anything CNCF before that because I had done a bunch of things, like I mentioned earlier. But the entire CNCF ecosystem started here because InfraCloud, we have contributed a lot to major projects upstream. And that's where when I joined the organization, I was tasked to work on Fission, which is a Lambda equivalent for Kubernetes. It's open source, function as a service. So that was my first project when I joined the company, and it was a CNCF project. And then while I was working on that, I started exploring the other set of projects which are present within the landscape. So you talk about Istio, you talk about Grafana, you talk about a bunch of other tools. So that's how I got into the CNCF landscape.
And how's it going so far? Like from the day you started and now, how was it like in a brief?
So I think the whole journey has been very interesting, as well as a lot of gratitude to folks and the community along the way, because in this short time I got to know a lot about the entire ecosystem, the various tools that are there. A lot of breadth-based learning for me. So that learning curve, I still tell my manager here at Improving that when I joined, I was probably here, but then the learning graph that could have been like this, or something of this sort, it just went like this after I joined, because a lot of things were thrown at me, and then fortunately I found them interesting. Like, how do I route traffic to a particular pod? I want traffic to go to A pod, I want traffic to go to B pod. How do I do the Istio? I'm like, whoa, that's how it works. And then looking into observability, Grafana, just plug in an Excel sheet, for example, and then you have a dashboard ready, and then you can tweak things with it. So I got interested in a bunch of tools, and then I started exploring all of them one by one. And then obviously, came to know about a lot of communities that are doing events and meetups in different parts of the world. And that's how I got associated with the CNCF Hyderabad community. So I was a volunteer, then I built something, and I was like, hey, can I talk about this? And the organizers back then were like, sure, why don't you come and talk about it? So I did that. And then one thing led to other. I became an organizer. Now I always look forward to inviting more newer folks to come and speak, because that's how I started my journey there. And that's how I reached at KubeCons and speaking internationally. So I definitely want more and more people to take that opportunity, grab it, take the stage, and go to different places and share their learning. So journey has been exciting. Yeah.
So since we are in the resilience testing talks, we would love to know about your first interaction with resilience testing. How did you got to know about it, and how do you define it for someone new to the CNCF, like cloud native systems?
Sure. So, like I said, I actually started as a manual QA. So I have been in the testing world for quite a bit time, and I've seen how it happens within the QA space, what we do. So whether it was doing the integration test, because while I started as a manual QA, that's what I was essentially doing. But then I also spent time building applications and solutions. So I know that unit tests are written to test a particular functionality, right? So these kind of tests, unit test will test your individual feature that you have written. Integration test will test a bunch of features plugged in together and then see how it basically works. And then system testing does the entire end-to-end complete system test sort of. So I was very familiar with all of this. Regarding resiliency, I think interestingly, while I was at InfraCloud, I was also taking care of the blogs that you see. So the technical blog that we have, I was one of the co-editors sort of while at that time. And one of the engineers submitted a blog post on chaos testing using LitmusChaos and something. And because I was a reviewer, I was just going through it. And because I was going through it, it felt new. It felt interesting as like, okay, there's something new that, I can kill stuff while something is running, and then something will happen, and then I can see what's happening that way, right? So while I was reviewing his blog post, I was also trying it on my own. So I had LitmusChaos installed on my system, and I was following his steps, also validating what he has written was correct or not. But then also on side by side, just running it on my Minikube cluster and just running those experiments that were there. So, deploying something, clicking that pod kill, and then something happened, and then how it responded, things like that. So I tried that. That was my first interaction with resiliency as a whole subject, and as well as LitmusChaos as one of the tools for performing chaos tests. And then obviously once I started doing this, I'm a history buff as well. So I spend a lot of time going behind the story of things, how it happened, whether it is tech, whether it is food, whether it is traveling. I'll always go behind and see how it started, because I think that helps me understand the whole genesis of how things are today, because it started at some place. So that's when I stumbled upon the Netflix blog, because they spoke about monkey testing and chaos monkey and the whole chaos engineering as a concept. So I read that, read bunch of other articles, and got a better understanding of resiliency as a whole. So today, if I have to define it to anyone, I would say your unit tests actually test the features or test the application and see whether it is working as expected or not. But resiliency, on the other hand, it actually tests how your system responds to failures. So what you would probably do is you might have, let's say, a functionality to validate an email address. So as a unit test, you will pass an email ID to it. You will check whether the regex pattern is working perfectly or not. You're getting a response. That's where your test ends. Your integration test, you might probably use an external service to validate whether the domain provided within the email is correct or not. So in your integration test, you will also test the external service. Now, where resiliency comes in is, what if that external service didn't respond to you in 1 minute? What if that connection dropped in between? Do you give a white page to your end user? What does your end user see? So I think a lot of resiliency comes from validating your systems, but I think it is also very important for user experience as well. And I would add one small personal anecdote over here. So I didn't mention, but I was building Android apps as a hobby, maybe 5-6 years ago. So one of the apps that I built was a basic calculator. You add bunch of things, it used to calculate and give you results. And one of my biggest fears at that time was not using any external service, and I wanted everything to happen within the phone. So I use SQL, right? So the data stays on phone, no network, no third-party APIs used. And the reason for doing this was I was scared, what if the internet drops? The app stops responding and app crashes. What if the database that I'm trying to call, right, it has some issues and it drops and suddenly it says your app is not responding and it crashes? So I didn't know the concept of resiliency back then, but I was worried about the user experience more. So I decided to figure out that no, I'm not communicating with the external world or apps. Everything happens on my phone. Everything is under my control, and nothing is going to crash. Now that when I came to know the whole concept of resiliency, I could have definitely applied this concept there and tested it before I released the application to public. So I would know how my external services are responding. What if I don't get a response, right? The app doesn't crash. How does it handle? And a bunch of other things. So yeah, your regular testing tests the features of your application. Resiliency tests how your system responds when something happens. Yeah. That's how I would put it in very simple words.
Thank you so much for that answer. And I think the next question that I'm gonna ask you is something that you partially answered it already. But since you belong to testing background, you have more insights about it. So the question is, how does resilience testing differs from the normal testing that we do? That is the integration testing, unit testing, load stress testing, and stuff like that. And what gap does it fill that normal testing usually is not able to fill it?
So as I spoke about resiliency earlier, what I understood from it and how do I put it into perspective. So like I said, when I started as a manual QA, I was working with a mobile app team, mobile device team instead. So we had a huge lab where we had a lot of devices kept, and we used to test these applications that were deployed and all the functionalities. So what I did pick up from there and putting all of this into perspective is all of these testing that we did back then was in perfect conditions. So everything was within our control. The devices, the battery on the devices, or the network that we were in, everything was under our control. So a lot of traditional sort of testing happens in perfect conditions, which normally doesn't happen, especially in distributed systems, especially if you have moved your monoliths to a cloud native application where you have a bunch of microservices thrown here and there. Then that the points of failures are many and a lot of things are not within your control. So you don't have a perfect condition anymore. Also, like I said, unit tests are more about focusing on, does this function work correctly? So I gave an example about checking the validity of an email address, right? So you might have a regex and you will just see whether the response is true or false, and that's what your unit test would actually check, right? So the unit test is limited to whether this function works or not. Now, talking about integration test, this is where you integrate it with third-party applications and then see whether these two services are working correctly or not. So it could be not only third party, but it could be other services within your application as well. So whether your login service is talking correctly to a forgot password service, right? So whether that communication is working properly or not. So integration test is essentially this, communication between services, between modules, whether it's happening or not. And then obviously you have the load test. So load test is how much traffic or how much stress your application and can handle. What if suddenly there are 100 people registering on your application, right? On your login page, trying to log in. How does your application respond? Now, while we are doing all of this, there are a lot of assumptions that we have, that the battery will be 100%, the network will be 100%, and then the user will do this, and then this will happen. So resiliency basically is what happens when the assumptions that you have made actually break. So what if the internet goes off, right? How will your application respond? What if the third-party service that you're using, that goes down? How does your application respond, right? If you have fallback, fallback options that you've created, how does your application or system behave and fall back to the options, that you have? So essentially, it's like traditional testing assumes that the entire infra is stable. And when it comes to Kubernetes, there's a lot of instability because of a lot of point of failures that are available. It promises self-healing. So a lot of us know that the moment we deploy a deployment set and a pod is killed, it will automatically self-heal and generate a pod for it. But we don't verify how it actually works, and that is one place where resiliency comes into picture. So your existing tests are passing with flying colors, everything is green. But what if a node drains while a transaction is happening, right? Traditional test won't catch that, and that is where you need resiliency to come into picture.
Thank you so much for that answer. I think you shared a pretty comprehensive guide on how does the resilience testing differs from normal testing that we do, that is unit test or integration test and all. But that leads me to the next question, that why is resilience testing important? Why is it essential, especially for the modern cloud native businesses?
Sure. So, like we said, traditional applications were monoliths, and monolith means one single code base, everything within that code base, and if anything went wrong, it was within that controlled ecosystem as well as the code base. Now, when we realized that we had problem maintaining such monoliths, we had problem scaling such monoliths. That is why the entire microservices architecture came into picture. So you break the entire monolith into smaller modules that are manageable, that are independent sort of, and then they communicate with each other through APIs or any other mode that you want. And with cloud native, that became a de facto sort of a standard. So today everything is microservice based, and all of them are distributed, which means that your login service could be written in TypeScript and work on a completely different language, while your backend could be written in Rust or Python and can be completely different. You will have multiple teams working on multiple services, and you could obviously scale up, down, do anything with each and every service independently. So we have moved from one huge application to a bunch of microservices which run on infrastructure that can change at any moment. So as the applications grow and as the complexities increase, businesses actually decide that we need to ensure that our services are on and running X number of time. We want to give, let's say, 99.999% SLAs, right? So you need a lot of different mechanisms to handle that. So what companies might do is that, hey, this service can be deployed in multiple regions, right? It could be deployed on multiple clouds as well. And internally what would happen, let's say you have a rule which says that if the ping is more than X value, you switch the request to another deployment of the same service. Now, this happens very quickly and you have no idea of what is happening, right? So the request from one customer would have gone to region X, but the immediate following request would have gone to region Y because of a lot of other rules that you have written, right? So the infrastructure is changing at quite a fast pace, right? And because of this, what happens is there are different types of failures that can happen, and there are different areas where failures can happen. So for example, the network between services or network partitions you talk about, right? Each service is operating in, let's say, a different infrastructure or different region, worked by different teams, and they're communicating via the internet. You might have a lot of internal VPCs created for them to communicate with each other. Now, each connect becomes a failure point because anything can happen over there, right? So network partitions become one failure mode. Your pods getting evicted and rescheduled. So because let's say your node is under stress, a lot of memory has been already used, and Kubernetes decides that, hey, I need to drain some pods, I need to get back some resources, and it kills your pod. Now this pod is gone, it comes back again, and what next, right? How does it connect with your existing setup, especially with stateful applications, right? So that is another case of failure, because in monolith applications we never assumed that the application would go down, but pods or containers essentially are ephemeral, right? They are meant to be ephemeral, they are meant to be stateless. So your pod can just go and come back again, and how do you handle that? So that's another point of failure. And at the same time, what happens is, because of this, there might be race conditions when you're deploying applications. So because so many moving parts, so many applications are being deployed, so many pods are being created and destroyed at one point in time, there might be a situation where two services are requesting for the same resource, and your application, your infrastructure or Kubernetes is prioritizing one over the other based on whatever rules you have, right? So the other service doesn't get the priority for whatever reason, and that's another point of failure. So how do you handle that situation? And then when all of this happens, obviously, these are not independent, right? I mean, the other services are there which are using them, or their output might be used by some other service, or they are getting input from some other service. So they all are part of a bigger application. So if there is one failure that's happening at one point, that is going to affect a bunch of other things. So there is a cascading effect that happens within your entire application, and that's a bigger challenge. So if you see, these all things are introduced only when we move to the microservices and cloud natives architecture, and these are the things which your traditional tests cannot do it. So they can just say that whether your function is working correctly or not, whether your services are working correctly or not, they're talking correctly or not, but they cannot handle what happens when the pod is gone, right? They cannot handle race conditions, right? So this is where everyone started using Kubernetes, and it promises a bunch of things like self-healing. It has resiliency built in, but are those capabilities built within your application, right? They don't come out automatically as well, because your application, while your infrastructure provides, your application should also be able to handle it. So without resiliency, it'll be like you are trusting your distributed system that it'll handle all the failures correctly, but unless that incident happens. So that one incident happens, and then you realize, okay, nothing works, but it's just you trusting on your system that, hey, everything's going to work fine, and apparently that doesn't happen in real life. So that is where resiliency comes in, and it helps you validate all these bunch of scenarios that you have gone through.
Cool. So since you already mentioned about the importance of resiliency in for businesses, could you share your thoughts on the recent outages that has happened in the past 1 quarter or some? Like we had AWS outages, we had Azure outage, and then Cloudflare. What do you think? What role resiliency can make during these sort of outages?
So I think one thing that all of us talk about when it comes to testing is testing production. A lot of enterprises are emphasizing that. And there are a bunch of ways how you can test your applications in production. So for example, A/B testing is a very popular way of doing it. Whether you talk about marketing or whether you talk about software delivery, A/B testing is a common way to test how your users are responding to the changes that you're doing. You have feature flags. So you can turn on a feature to a certain percentage of your user base and then understand how they're responding. So testing in production is very critical. A lot of companies are doing it, and there are established ways to perform that sort of testing. But then when it comes to dealing with infrastructure at that scale, that is something I feel, because I've not been directly involved with a lot of teams in production and at that scale. A lot of teams would have practices in place on paper. So they would have everything on paper that says, okay, if this happens, this will happen, and we are sorted. But incident like these will actually give them a wake-up call that, oh my God, whatever we thought will happen, it didn't happen. And that is where, while a lot of companies focus on disaster recovery or, backup plans, things of that sort, because obviously data is critical. Those are some things that a lot of time companies focus on, that whenever there is an outage, we don't lose out on data and we have everything in place. But how does that automatically happen, right? How quickly is your system able to come back? Those kind of things will happen only through resiliency. So as someone from QA background who has come here and seen and has interacted with a lot of people, I think resiliency should be a part of their plan, right from the beginning. And what it can do is it can help you test exactly these scenarios. You might not, like I said, you might assume a lot of things, that these are the assumptions, and based on those assumptions, you do a lot of things. But what if those assumptions prove wrong, right? And these kind of outages tell exactly that. For example, if one of the recent issues of Cloudflare going out, I think a few weeks ago, and we have a very popular app in India called Zerodha. I think you would be aware of it. But for everyone else, it's basically a stock broking application. So we can invest in equity and commodities market. And the moment Cloudflare outage happened, I got a notification on my mobile app that, hey, this outage has happened and our services won't be available. However, if you want to execute your trades, you can use our WhatsApp service. So that company was quick. They already had assumed sort of that these might happen. While they would have obviously tested their application for this outage, but they had a backup in place as well. So, I'm sure that there won't be a person sitting over there and checking, okay, Cloudflare has gone down. Let me write a WhatsApp notification to send it to all the people. I'm sure this would be a resiliency check in place over there. The moment if Cloudflare has stopped responding, if some services have stopped responding, immediately take that clue, trigger something, and then do something. So, I think we discussed quite a bit, but we didn't touch upon observability as said, because resiliency cannot come until unless you have observability, until unless you can see within your systems what's happening, what are the signals, what's happening. Until unless you don't have that, you cannot build a robust and resilient system. So, TLDR, you need to have such plans in place. Observability number one to get the signals right, and then obviously build plans based on your logic, your customers, the importance of the applications that you have, etc.
I think what you said is fairly correct. A lot of companies do have everything on paper, but they don't really test it and they don't really perform chaoses with a different sort of scenario that might happen. But eventually, when something like these sort of outages come into the picture, and then they understand that, hey, this could have been done before and now we are in trouble, right? So the next question is, from business perspective, what impact does resiliency or lack of resilience testing can make an impact on first user experience, second is reliability, and third is trust?
Sure. So, like I said, I'll tie back to my days of building Android applications. I always cared about the user experience. And trust me, users like you, me, everyone who's watching this, we don't care about the internal architecture of your applications. We don't care if Instagram is a monolith or if X is microservice based. For us, it's important that your application works. When I want to post an image, I should be able to post it. When your service is slow or unavailable, for me as a customer, it's a broken product. I will go to another option, or I'll delete the application or do whatever that's possible, right? So for the end user, it's not important what your architecture is, but the experience is more important. So how gracefully you handle the failures in your application, right? How gracefully your application handles anything. It could be a timeout issue, right? A lot of times I have used applications where it just times out and it gives me a blank screen and I have absolutely no idea what has happened. Some other applications will show me a cat over there roaming on the screen and says that, okay, we are trying to fix a bunch of. So I, as a user, know that, okay, it's not my fault, it's server's fault, something has gone wrong, and I get an idea. So I think I see resiliency testing as a bigger thing for user experience, obviously, because we can test bunch of real world scenarios, and how your application will respond to it. So obviously, number one is the user experience. Second, obviously, is reliability. When you are talking about resiliency, reliability goes hand in hand, because in a way, when you are testing your application, for resiliency, you are going to have a bunch of scenarios that you will test, which probably your traditional testing will never consider. So you might not even have a plan of doing that. What if I shut down my database server, or what if I turn off my message queue? What will happen? So these kind of tests are usually not written. Test would be like, I'm sending a message, it's storing in a queue, what's the response time? That could be a test. Your response time should be within some milliseconds. That's a valid unit test sort of. But you don't really actually test how your system will behave when something goes wrong. So every incident has a cost associated with it. Anytime like Cloudflare went down, a lot of services went down, and there was a cost associated with it. Obviously, a lot of time you will see it as a revenue lost, because you would have guaranteed as an enterprise that we will give you uptime of so and so 959s or 69s, but then because of this outage you are not able to commit to it, so you have lost revenue. But then I think revenue is just one part of team, or one part of the whole picture. You lose trust from your customers that this service doesn't work a lot of times. So I might want to look at options. Secondly, within your engineering team, your team is always on a firefighting mode, because if your application and if your infrastructure is not stable, is not reliable, they are always anxious. The moment a deployment goes, the entire team will be on their toes that what if this doesn't work? What if something goes wrong, right? So your team is now focusing on firefighting issues rather than building on new features. So this entirely slows down your deployment cycle and affects your competitive edge in some way or the other. So if you're competing with some other enterprise on certain set of features, you will lag behind because your team doesn't have bandwidth to develop features, because they are stuck with making your systems reliable, right? So that is a part. And I think the third one was trust, which I mentioned in both this thing, right? The users can forgive bugs, right? If there is a small bug in application, they're like, okay, fine, it's fine, it happens, sort of, right? But then they cannot forgive outages. That's how I've seen, right? The moment a service goes down, you go to Twitter or X and you will see memes coming out of it. You will see a bunch of things happening, right? So if there are minor bugs, people can still forgive it. But then when your application doesn't work for long hours, that is when your trust is affected. So if there is repeated outages that is happening, or if a customer data is lost in the transaction because you didn't test for it, you didn't know how your application will respond. For example, a lot of us fill a lot of forms. You talk about visa forms, you talk about admission forms, you talk about anything. We fill a bunch of forms. Now, what if you have filled a form, you submitted it, something goes wrong in the network, the data is not gone to the server, it's gone from your UI, and then imagine sitting and filling that form again. You are not going to do that again. You are gone. Your customer is gone from there, right? So of all of this, trust is very important. And I think when you do this kind of testing, when you do resiliency, when you kill a pod, when you kill a service, when you introduce latency, you are actually trying to test in production without being in production, but dealing with real world issues, and picking up a bunch of things and creating a realistic scenario will make your application more stable and reliable. And that way your team would be confident that yes, this application can handle anything that goes wrong. There will be more trust within your team as well, because your team is trusting it. And when you have handled all of these scenarios, your customers would also trust, because these outages would reduce from a huge number to a smaller number, right? So trust is third thing that is very critical.
Thanks for sharing that thought, and I'm pretty aligned with what you said on how resilience testing can make an impact on first user experience and reliability and trust as well. So now let's chat about the fundamental question, that is the elephant in the room, that is how do we start, right? So initially when people know about this concept and this practice, they do feel overwhelmed with, because there is so much of learning curve involved in this, right? So how do we get started? Like, what are the initial few steps anyone can take in order to just get started and then scale it later on if they feel like?
So speaking from my experience first, like I said, I was reviewing a blog post, and that's when I stumbled upon chaos engineering as a concept, then stumbled upon a bunch of tools, LitmusChaos being one of them. And all I did was deploy that application to my local Minikube cluster and picked one of the ready-made experiments that they had and just played around with it. So I think if you want to implement resiliency, and especially use any of these tools, it's important that your engineers or anyone in the team has some experience while doing it. So most of these tools are, like, for example, LitmusChaos is open source, right? You can just download it, deploy it on your local cluster or wherever you're using it, right? It's super simple, runs a bunch of Helm commands, the application is ready, they have experiments in place. Just try killing a pod that you have. So create a hello world pod, kill that pod. Create a hello world pod, add an ingress service, kill that ingress service. You will see 500 error on the browser, right? So you kill something, you see the response, and then you keep trying all the experiments that you have. So that way you will have an understanding of how the tool works, what chaos engineering actually is, and what happens when you do what and how your application responds sort of. So like I started with a hello world example, and then I did a demo at one of the KCDs where I used LitmusChaos to validate istios. So I had a virtual gateway, I had istio pods running. So what if I killed a istio pod, right? How will the traffic go? Will it go to my application or not? So these type of chaos failures I introduced using LitmusChaos within the istio namespace, and I was able to demo that. So I think the first thing is trying hands-on. So people, engineers in your team would not only know the concept of chaos engineering, but then also try out the tool. And then once they are confident, I think in terms of a phased approach, if anyone wants to take, the first thing, like I said earlier, was observability. So observability is the first thing that you need within your applications, because you need to be able to see things when some things break, right? So what happens when there is a latency in the network that you're using? What if the response comes in late, right? What is happening within your infrastructure? What's not working? So you need to have observable system in place first. So, ensure that you have logging implemented correctly, you have metrics there, you have tracing there, you have auto instrumented your code if required, right? So you have proper visibility within your application, so that you know that if there is a latency here, this service is affected, and this is the function that is affected, and this is the way it is going to respond. So first, obviously, make your system observable, have an observability solution in place, have your logging metrics and tracing done correctly. Then you pick up one simple flow within your application, which is smaller to test, to pilot on, rather than going on something really important. You don't need to try to chaos your entire application right on the word go. So if your application is deployed, you don't need to go and start killing all the pods, start introducing failures, start having latencies and bunch of stuff like that. Don't look at the entire application. Start with one service, and it could be a very simple path, sort of, let's say a login path, right? So user just enters the credentials, clicks on login, it goes to the server, checks the credentials, and comes back. So this could be a very short but critical user flow that you can test here. So you'll have your service communication, you will have APIs in between, you have your different pods and different microservices that working. So you can focus on that. Now, once you have identified your path, what you can do next is, within the tool that you have chosen, there are by default some experiments that are available. So I spoke about downloading one of these tools, LitmusChaos, for example, right? You have a bunch of experiments there, specific to cloud, specific to network, specific to storage. So pick one of those from it and apply to the critical user flow that you have chosen. And it could be something very simple to start with. So the most simplest chaos experiment can be killing a random pod. So within your user flow, when you have the login flow that you are working on, there might be multiple pods from the login service, the front end service, bunch of other things. Apply this experiment and choose one of the pods by, can select that by a namespace or by the attribute. Choose a pod, kill it, and then see what happens. Does your application start giving some random errors, right? Or does it work perfectly fine? So that could be your starting point. So you can use a pre-built experiment, the most simplest one, apply it and see how it happens. Then you can obviously add in more experiments depending on the kind of scenario that you expect would happen over here. So apart from randomly killing a pod, what important scenario that you can check would be the network. What if your server didn't respond in time, right? Or what if the input that came in from the server was not in a correct format, or bunch of things like this. The power went off, right? There was an outage and absolutely there was no response that came in. Or maybe the server that was dealing with the state, the PVCs, that pod completely went down, or something went wrong with those clusters. So you can imagine the scenarios that can take place, and then accordingly either use the pre-built experiments, which I feel are very good for most use cases, or you can write your own experiment depending on if you have a specific scenario. So you do that, and once you are comfortable with that within the scenario that you have chosen, you can run this in a non-production setup. So run it on your dev machine, run it within your staging environments to gain more confidence. So you know that the resilience tests that you have applied over here within your application how does that perform? Run it a couple of times, run it at different staging, different environments before you actually go to production. And once you have all of these working fine and you have the confidence, you have the trust that your resilience experiments are working fine, your application is responding well, your infrastructure is working fine, then you can automate this entire part and make it part of your larger CI/CD pipelines or GitOps processes that you have. So once you have the basic experiment in place, automate it, and then run it every time before a deployment goes into production, right? So you don't do it as a one-off exercise. Make sure that it becomes part of your regular deployment cycles. And I think that would be the most matured level according to me when it comes to implementing resiliency, right? So you start with on your local system to making it part of your CI/CD workflows, GitOps workflows, getting directly into production. So I think the key over here is, don't think that you are breaking things, you are breaking your application, but instead you should have a mindset where you are focusing on that. By doing all of this, you're just validating the assumptions that you have about the system on how it responds within certain scenarios. So you're just validating your assumptions. So that should be your mindset, and it should not be that I'm going ahead and just breaking a bunch of things in my application. So yeah, that I think should be a process which teams can follow.
I think you gave a pretty good getting started guide, like how can you start small and then what are the things that you can do around, and then you can scale it gradually, right? But now let's address the facts, right? Let's address the problems that we might face. So the question to you is, what are the main obstacles team might face from both technical and organizational point of view while performing the resilience testing?
Sure. So earlier in my intro, I mentioned that I am part of the platform engineering technical community, and I've spent about a couple of years with a bunch of practitioners from across the globe, and all of them are pretty experienced. Some of them are leading platform teams, some of them are building platforms, some of them are using platforms. And one thing that I learned from all of those discussions was that tools are never a problem. It's the people, it's the processes, it's the organizational culture, it's the organization, it is just how the organization works, which is a major area of concern. So once you have that out of your way, you have a bunch of tools to do things. But it's the people that you need to tackle with, it's the people whom you need to deal with. Once you have them on board, then you have the other headache about choosing the tool, implementing it, so on and so forth. So I would like to start by focusing on organizational obstacles, right? And I think one of the critical things which I'm sure a lot of people over here would relate to is the time pressure. So irrespective of what industry you are in, I think there's always a pressure on the engineering teams because they want to ship features faster. They always are in a hurry that, let's complete this sprint, let's have this new feature implemented, let's just ship it, send it to our users, get the inputs coming in. And within this process, resiliency testing is like a hurdle within the entire thing. They'd be like, hey, I can do something in 10 days. You are adding a layer of resiliency testing, which will take another 2 days. My, shipping will be delayed, and it's going to affect a bunch of other things. Now, this may or this may not happen, but unfortunately, there's the assumption that a lot of people have. And because of that, a lot of people are not even ready to adopt it. Similarly, when this multiplies or goes at a higher level, so this is probably what a product manager or an engineering manager would think. But then when it goes to a higher level, for them, it would be like, hey, if it's working, why you want to fidget with it? If it's working, let it just be as it is. Why do you want to, induce something to it and then suddenly something goes wrong? We talk about it every time, right? Any engineering team, you say if the one thing would be like, if it's working, don't touch it, irrespective of what it is, right? And here you're talking about breaking something that is working, which is like a nightmare for anyone. At one side, you are telling people don't touch if it's working, and as resiliency, I'm saying no, let's break what is working. That's another mind shift that is required at that level. Then obviously there is lack of awareness by a lot of engineering teams. I think we discussed this at our meetup as well earlier, that while a lot of people know the term, a lot of people don't know what exactly it is, how to start with it, how does it happen in practice. A lot of people, when they read about chaos, they would have come across monkey testing as a popular term earlier, right? So I've read it at a bunch of places. Chaos is basically monkey testing, and that's basically how a monkey would test, go like this. But that's the only thing people know, right? But then how do you actually implement it within your systems? How do you implement it within your distributed systems? How does it work in Kubernetes, right? These are the things that people are not aware of, and I think more awareness is needed on those fronts. And I think this podcast or a bunch of things that we are doing, right, this will help improve the awareness for various. And I think last thing from an organization perspective could also be about ownership. When you are working in enterprises, there are a bunch of teams taking care of a bunch of different things. You don't have one team doing everything, especially now with platform engineering coming in. You have a dedicated platform team, who is responsible for building a platform, abstracting a bunch of things, giving you all the services that you need, right? Then you have an SRE team, which is ensuring that all your services are up and running, monitoring and doing a bunch of things. Then you have your DevOps teams. Then obviously you have your dev team. Then obviously you have your QA team. So who owns resiliency? Is it a QA thing? Is it that my QA team will own it? Or is it that my platform team owns it? Because it includes a lot of platform work over here. Or is it my SRE team? Because it's the duty of SREs to figure out whether my application is or my platforms are working fine or not, right? So ownership ambiguity becomes another problem. And when you don't have an owner, none of the initiatives work. And it's not only about engineering, any discipline you talk about. If you have an initiative, if there is no owner for that initiative, it's not going to be successful. So I think between all of this, ambiguity, awareness, the complexity, a lot of people don't want to break what's working. They don't want to have their features delayed. So time pressure is always there. There's lack of awareness, and then obviously the ambiguity that comes in. So these are issues from an organizational perspective. Now, coming to technical perspective, obviously, a lot of teams, when they start, they don't have proper observability in place, because if you cannot see how your system responds when something goes wrong, you cannot validate whether your system is resilient or not. So you just be breaking things blindly. It's like, shooting arrows in the dark. You know what's happening, but you are just shooting and you don't know if it's going to hit the target or not, right? So not having proper observability in place is one of the technical concerns. There's also some fear that you might break production, and unfortunately, or that's not ever going to happen, because you are not directly going to be doing it in production, because there is a stepwise process in place. But then a lot of teams have that fear that, hey, if I do something, if something breaks in production, then the application is gone, right? So if you don't have proper guardrails in place, then this is definitely valid. So that is where the entire platform comes into picture. You need to have a solid platform with solid guardrails in place. So that ensures that whenever you are doing a resilience test, especially on production, you are not going and doing rogue activities or going and breaking things that will actually go and affect your application or production. So you need a platform with proper guardrails in place. And then another problem which I feel is people don't know where to start from. They have huge applications, many services, many modules that are working in. Where do they start from? And I think that's another confusion which holds back a lot of teams from starting their resiliency initiative. So I think, and these technical issues coupled with organizational issues convert into bigger issues which halt the entire process. So first, people not being aware of it is one. The ambiguity is another problem. And then you couple that with fear of breaking production, it just multiplies. The entire thing becomes 100x suddenly. Your people don't know what to do. They are fearful that they'll break production. They are never, ever going to do this, right? So it all starts with organizational changes. And then, like I said, technical changes would come in later on where you can fix those.
So as you mentioned about I'll talk about the organizational obstacles that you just mentioned. So you mentioned that there is a lack of ownership that can be one of the biggest obstacle when it comes to applying resiliency in your organizational infrastructure or whatever, right? So my question to you is, how can we solve this? At the end of the day, we want to have an owner. So you mentioned about different sort of teams that may or may not be responsible, or they all of them can be responsible because some part of it belongs to them, right? So in that case, how can an organization handle the situation, and how can they initiate this practice?
So to answer this, I think I'll focus on two aspects based on, again, a bunch of discussions that I've had with a lot of people. The first one is having a product mindset, and second one is having shared responsibilities. So when you talk about product mindset, this is where you include all these stakeholders while you are building your application, while you are setting up your infrastructure. So you have representation from your developers, from your QA team, from your SRE team, from your DevOps team, from your platform team, from your marketing team, from your finance team, from your legal team. So everyone is involved in the discussions when you are building it. So when you are involving all of them right at the beginning, you will have inputs from everyone at that point in time. So if there are any concerns, that could be plugged in earlier in the stage. And that's very easy to fix rather than fixing it at a later point in stage. So what happens when you have all the teams on board, you get a clearer picture of what are the friction points that can be there. There are a lot of critical handoff points over here, right? So developer will build that application, package it, and then they hand it over to DevOps team, which will deploy the application, then hand it off to the SRE team, and then hand off. So there are multiple point of friction, multiple point of failures. So I feel when you get all these people on board, you can clearly identify the point of failures, and then automatically when this visibility comes in, your ownership would automatically be in a way implicitly defined, sort of. So when people get to see, a lot of problems, like I said, is visible. A lot of people are not able to see what's happening. So once they're able to see, that they'll be like, okay, this is something related to the infra that we are managing. This is something that will come to the SRE team. We'll take care of it. And that is where the whole concept of shared responsibility comes into the picture. So once you show them the end-to-end flow, be transparent and show them that this is exactly how this is going to happen. These are the touch points within the organization. These are the touch points as infrastructure. This is going to touch the data team. This is going to touch the network team. This is going to touch the security team. Once you do all of this, then each and every team will implicitly, because they have a better visibility now, will obviously say that, okay, these are the things that pertain to us. We'll take care of this. So eventually what might happen is there might be teams who might be owning the experiments for certain things. So if you are do something around data, for example, right? So your data team can be owners of the experiments that are created, and these experiments would be then on the platform, which your platform team is responsible for. So your data team is essentially owners of the experiments for the data part of things. Similarly, your network team can create experiments for the chaos experiments for networking. And that way, the entire responsibility is shared across everyone. So you have shared responsibility, and this will automatically bring in standardization as well. So once the network team writes a chaos experiments to validate some VPC or how a particular service behaves, that becomes a standard that in the entire organization, wherever resiliency is happening and where they want to test this particular scenario, is going to be this chaos experiments that happen. So your platform can take care of the platform, which is there. Your different teams can work on different experiments that each of the teams relate to. And that's how the whole shared responsibility comes in. And this happens when you have the product mindset, which brings you more visibility, which brings you more stakeholders. So yeah, that's how I feel we can probably solve this problem.
I think what you mentioned is so true, because when I got to know about resiliency and reliability, I started reading a lot of blogs and stuff. So in one of the blogs, it was mentioned that resiliency or reliability is not something that you do at the end. It is part of your architectural process that should be along with whenever you start building, right? It's a part of building process that you identify it, like it should be on your back of your mind that, okay, this is something that we're going to test about, right? and this is what something that you also mentioned in a way. So yeah, thanks for that answer. So this is the last question I wanted to ask you, and since we are living in the age of AI, and me not asking this question will not be fair for this podcast. So the question to you is, how does the emerging tools like MCP can play a role in making resilience testing more accessible, adaptable to the teams or the organization who are using it? So AI is pretty much used in most of the organizations right now to make uh, things efficient and make things faster and quicker. But in this niche or domain, how does it impact is the question.
Sure. So I think I'll go back to the awareness concern that we had spoken about, right? A lot of people are not aware of it, and a lot of people still might believe that you need to have the Netflix level sophistication to do chaos testing, even though you have a lot of tools and a lot of options available right now. So I think with the advent of AI, specifically with, let's say, MCP, if anyone who is using AI to write code or using it to build experiments or do anything, if they are already using AI, the addition of MCP, what it will do is it's going to reduce that barrier of entry for a lot of people, because now everything comes to conversations. So what will happen now is, as a developer, as a QA, I'm going to talk to my system and say that, hey, this is what it is. I want to see how my application responds when the response is not received in a particular time limit. So I am speaking naturally, but then because I have an MCP in place which goes and checks my system, right? So for example, you talk about the Litmus MCP, right? It's connected to my control plane over there, and it actually knows what's required. So with AI, I might not need to have the full level expertise of the tool of Litmus in this case, but because the MCP is there, because AI is there, I can just talk to it and it can go and perform the actions for me, right? So instead of me dealing with the YAML scenarios, instead of me dealing with bunch of other configurations, the MCP will handle everything for me in a way, right? So that dramatically reduces the barrier of entry. Plus, with AI advancing, what is also going to happen is when you provide better context to AI of your system, so it not only understands your code better, but it understands your entire system in a better way. So what it is going to do is it can help you identify better chaos scenarios that can happen, and that's going to be very powerful for teams who don't know what to test. You cannot go ahead and just kill a pod and kill a network service and say that we have implemented resiliency, right? You need to also know where to put where you should have your chaos experiments implemented. And I think with AI, with better context, it can tell you exactly that, hey, this is an area where you should put an experiment that can test this things, right? So AI assisted scenario generation could be a completely different area that can come in. And then obviously, there's a lot of there's a lot of advancements that have happened in the tools itself, right? Earlier, a lot of these were maybe only CLI heavy, but now a lot of them have better dashboards, which is easier for people to use, right, to get used to it. Or they also come with a lot of different form of integration points as well. So they have APIs, they have webhooks. So it makes easier for developers to adopt and integrate with their chaos experiments. And then obviously, with things like GitOps coming into picture, you can version control the entire chaos experiments and make them more repeatable and make them work in exact the same way as your applications work. So I think the tools have improved a lot. AI has come in big time, and it's going to reduce the barrier of entry for a lot of people. So all in all, it's going to make lives much more easier compared to a couple of years ago.
So as you mentioned about of implementation of MCP with different set of scenarios that we can use in resilience testing, we at Litmus also have released MCP server, and I think I gave a talk about it at CNCF Hyderabad only. And previously it was like taking a lot of time to understand how to create experiment, how to implement them and stuff. You need to understand your own infrastructure in case if you're not used to it. Only few people in the organization know that, okay, what are dependencies, services and stuff like that. Now MCP coming in the picture, you just write it down that how it is like what should I do it, like what are the first set of resilience tests I can perform, and AI will give it to you. And previously you need to figure it out on your own, how should I do it and stuff. But now with the advent of AI in this niche is like, uh, it can make a big
Super helpful.
difference. Yeah, exactly.
Yeah.
Yeah. So that is there. So with that, we would conclude today's podcast. And thank you so much, Atulpriya, for sharing your insights. I think whatever we had a conversation on in today's podcast, something super valuable to all of them, especially who are new to this and who are planning to adopt it, but they something is holding back them. Okay, what if this, what if that? But I think you answered most of the questions, of all the questions people might have initially before start implementing it. And thank you so much for sharing your knowledge and thoughts on this podcast. Yeah.
Yep. Thanks so much, Pritesh, for having me here. It was great talking about resiliency and everything chaos. Like you said, I'm also a newbie and I've spent some time, learned the entire, not the entire, but learned quite a bunch of things within the space. And yeah, I just hope that whatever we discussed is helpful and more people are aware of it and start implementing resiliency within their, life cycles from day one.